Okay, hello everyone. In this video we're going to be looking at finding the displacement from a velocity versus time graph. Okay, so here we've got a graph, time in seconds running along the horizontal axis, velocity in meters per second west running in the vertical axis, and you can actually see above each one of these sections it tells us what the acceleration is. So we're not really going to be spending time doing any kind of accelerations off this graph, but it is across the top if you wanted to look at it. So the idea is, by looking at a velocity versus time graph, you can't just see what the displacement is. We have to do a calculation of area underneath the curve. So I'm just going to break it into some smaller pieces, some shapes that we're able to calculate the area of. So just by making a few simple lines, I have turned this odd shape into some triangles. So A1 is a triangle, A2 is a rectangle, A3 is a triangle, A4 is a rectangle, and A5 is a triangle. And now we're just going to go through the process of finding the area for each one of these 5 shapes. And then the total displacement for this time interval, which is up to 100 seconds, will be the total area underneath the curve. Okay, so let's start calculating our areas. Area 1 is a triangle. The base is 10 seconds. The height is 30 meters per second. So area of a triangle is 1/2 base times height, or base times height divided by 2. Base was 10 seconds, height was 30 meters per second west, divided by 2, which gives us 150. Now the reason why the units are meters is we have meters per second times seconds, which would give us meters, and the vector direction is west. Area 2. Base is 20 seconds, height is 30. This is just simply a rectangle, which is length times width, or base times height. So area 2 is base times height, 20 seconds times 30 meters per second west, which gives us an area of 600 meters. Area 3 is a triangle. The base is 10 seconds. The height in this case is only 20 meters per second. So 1/2 base times height, 10 seconds times 20 meters per second west divided by 2 gives us an area for region 3 of 100 meters. Region 4 is a rectangle, 20 seconds by 50 meters per second. 20 seconds times 50 meters per second west gives us a grand total of 1,000 meters west. And the last area, area 5, the base is 10, 20, 30, 40, 50 seconds. The height is 50, and it's a triangle, so 1/2 base times height, 50 meters per second west times 50 seconds divided by 2, giving us 1,250 meters west. Total displacement is the area underneath that curve, and I've just rewritten all of the values, A1 through A5, and we'll notice that they're all in meters, they're all in west. Add them all up, and we get a total displacement, or total area, of 3,100 meters. You can also have velocity time graphs which have components above the time axis and below the time axis. So I've already divided this into sections that are easy to work with. We've got our triangles and our rectangles, and what we're going to do is the exact same thing as before, find the area for each section. So for A1, base is 10 meters, height is 30 meters per second. It's a triangle. So area is 1/2 base times height, which will give us 150 meters west. Area 2, the base is 20 seconds, the height is 30 meters per second west. It's a rectangle, length times width. Area is length times width, 20 seconds times 30 meters per second west, area of 600 meters west. Area 3, it's a base of 10, 20, 30 seconds, height of 30. It's a triangle, so 1/2 base times height. So 30 seconds times 30 meters per second west divided by 2, giving us 450 meters west. A4 is a triangle. The base is 10 seconds. The height is minus 20 meters per second west. So now that we have these areas underneath the time axis, they'll actually give us a negative value. So we have 10 seconds times negative 20 meters per second west divided by 2, giving us an area of minus 100 meters west. Area 5, base is 10 seconds, height is minus 20 meters per second. It's a rectangle. Area 5, base of 10 seconds, height of negative 20 meters per second west, total area of minus 200 meters west. And the last area has a base of 20 seconds, has a height of negative 20 meters per second west, and it is a triangle, 1/2 base times height. So base of 20 seconds, height of negative 20 meters per second west, divided by 2, gives us a total of negative 200 meters west. So now the total area for this entire trip is the sum of all of the areas. We'll just list them out. We have positive values which were above the time axis, we have the negatives which were below, and when we sum them all together, we get a total area which is the total displacement of 700 meters west. And just to recap, the displacement of a velocity versus time graph is found as the area under the curve. Areas or displacements above the time axis are positive. Areas or displacements below the time axis are negative.